and welfare, all the professors, and on my dear students. Yes, of course, this is remotely we are connected, but I think we can do more effectively than the classroom session. I believe in that. So keeping that, just I'll take I have more slides, but I'll cover in the given time. I think probably by 1 hour time or 45 minutes to 50 minutes I'll cover, but a couple of slides just I'll read and not go through in detail. But anyway, I'll touch upon. But a couple of things that I highlight what is important for you, and then what you can look at. So if you have any question to me, please keep the question till the end. And if you want, you can ask directly, or you can put in the chat or the message box. You can just type in. I can answer your question at the end. So, or even whenever you get a question, you are feel free to put that in the message box. So at the end, I'll answer that question. So with this, I just start. I'll share my slides to you. So is my slides are visible?
It's coming, sir.
Yes, sir.
Yes,
Okay,
yes, sir.
thank
It's
you.
visible.
Yeah, my topic, what I just taken today is basically the 3D point cloud. I don't know how many of you heard of 3D point cloud. Anybody heard of it? 3D point cloud. If you're not heard of it, this is very simple. I'll explain you what is this 3D point cloud. How relevant that to the 3D printable objects. Very simple. So this topic I just given this the talk somewhere in 2014 in one of the mechanical automotive conference in Bangalore. At that time, it was very new. The 3D printing was very new. That means about 3-4 years old at that time. Today it is more than 10 years old. So at that time, this topic because they invited me to give the talk, but I'm an electronics person, so what to do? Just thinking, then I just related the 3D point. I am working in the 3D point cloud. So 3D point cloud to 3D printable objects. So this is the topic which I'm going to take you through. So we look at the definition. I'm not going to explain you in detail. So what is this 3D printing all about? So what is this is a buzzwords today. We are using this in the market. Whether you go to aerospace, whether you go to the film industry, many industries are talking about the 3D printing. So what is this 3D printing all about? The process of making physical object from a 3D digital model. So you are experts in making a 3D digital model. So from that you create a physical object. That is a 3D printing. So building products through a successive, thin layering of a material without the intervention of cutting, drilling. So for example, you take a conventional manufacturing, conventional mechanical industry. So a lot of cutting, drilling, all these things. So here, without doing that, using the successive thin layering of material, any material, composite material, any material, so build the product. Then the type of industrial robot using a 3D computer CAD program to create a digital model. So this is a very simple definition, 3D printing. Okay, so with this definition, so what are the benefits? I think if you look at the benefits, 3D printing, which is offering today, is a mold-free manufacturing. I think all of you know, you're all experts in making the mold. So it's a mold-free manufacturing, and the turnaround time, or the fast turnaround, takes the less time. High-quality products in the short runs, maybe about 45 minutes to 50 minutes. We can print any object what is required. High-quality product. Complex designs also we can do it here. Lightweight functional parts we can make it. A lot of things. I think if you look at that list, there's adaptive quality control. So say customize the same product according to your need. So for example, you want to make one product, you can make a product, then another product you can make in a different way. So that is positive. These are the benefits of this 3D printing. So now if you look at how this development through time happened, it started way back in 1984. This is started in the first form of 3D printing invented in 1984. Then in 1992, the first 3D printer is built. Of course, it's mainly in Germany. Then functioning of kidney is created in 2002. Then in 2006, the 3D printer can now print the multiple materials. This was done. Then the 2008, the prosthetic leg is created for the disabled people. In 2009, the 3D printed blood vessels was developed. So like this, it is happening. So maybe 1984 till now, a lot of things are happening. If you look at that, the era 1986, the Chunk Hull patented the stereography and founded the 3D systems in 1986. In 2030, the world's first 3D printed gun, created by the Cody Viscon. Then like that, 2014 to 2016, the expiration of key 3D printing patents were done. So like that, this is award. Now today, everybody is talking about 3D printing, and everybody is using this thing. So it's becoming a part and parcel of the industry today. Anyway, I'll just end up my presentation. I'll show you overall using it, how they are using it. So how does it work? Simple. A person creates a 3D image of an item using the CAD software program. So that is, you are all experts in that. You create a 3D model, using a 3D software, CAD software, you create a model. Then the CAD information is sent to the printer. Simple. I think you just take a pen drive, insert into the 3D printer. Then the printer forms the item by depositing the material in the layers. Maybe that's what is called additive manufacturing. So layer by layer, it makes the things. So in some cases, light or lasers are used to harden the material. So this is also a part and parcel of the 3D printer. Okay, this is how this 3D printing the system works. Okay, now coming to the basics. So now I think I don't know many of you heard of it. This 3D information visualization. Today we are now talking about the Facebook, Instagram, or the many things. I think you just take the app. There are many things. Yesterday I was browsing through one thing. So if there is a negative energy within the person, within the house, within the institution, within the company, how do you identify? So I want a 3D information visualization. Is there really negative energy available with all these things? If it's available, how can I visualize how much negative energy is there? Next is how you remove the negative energy. So this is, I wanted a 3D information visualization. How do you develop? So it's simple. You have a CAD software, you have a CAD model, then you have the facility to acquire the energy or the data, information. So get that information, whether it's not typically we get in the 2D. So get that information in the 3D, then I want a visualization. So this 3D information visualization is the next big revolution. Maybe years to come, in next 1 decade or 2 decades, this is going to be a big one. I think today, you are seeing that. So today we are talking about the COVID-19. So COVID-19, so if you just give in a text, who will read? Nobody will read. Suppose if I put that in a visually represented, that means in the graph or the whatever, there's a various form. So people look at. So that's the 3D information visualization is the next big revolution where mechanical and the mathematics people have a big role to play here. So mathematics and the mechanical. Okay. So now what is maybe just to look at what is information visualization. So various people said various way. The use of computer supported interactive visual representation of abstract data to amplify the cognition. So that is a visualization. Or this is what this person told. And other definitions, process of analyzing and transforming non-spatial data, not the spatial data, into an effective visual form. This is what the data visualization. So this is what I said. Highly efficient way for the mind to directly perceive data and discover knowledge and insight from it. This is a visualization. Or visual appearance of data objects and their relationship. Or the transformation of abstract data to a visual representation which is rapidly understood by the user. So this is some of the definitions of the 3D printing. Why it is important? So people talk about. So human beings are tremendously influenced by the sensory perceptions. The way that we learn, grow, understand, adapt is based on our ability to view and perceive and conceptualize the thoughts and ideas. So this is basically important. Then this is just power to visualize and graphically represent the results. Anything you take it, if you're able to represent graphically your idea, your result, solution, problems, so you can we can understand better than that. So this is a big revolution in the technology, because now today we're talking about the data scientist, data science. So what is the data science? They get a data, they get the algorithm, they develop the model, but how do you represent it? So this is the way, the computer visualization is the way for a data scientist. So maybe if you just take a Facebook today, Facebook is getting so much of information. Per every second, you get millions of data. How do you represent that? So this is the computer visualization. Okay. So now what are the dimensional types of information visualization? One is called temporal. I think all of you are aware. So second is the one-dimensional. So this is the one I think all of you know. So second, two-dimensional, 2D model. Then the three-dimensional. Then the multi-dimensional. Then the tree. So these are a couple of dimensional. Example 1D, 2D, 3D, whatever. So how do you represent the data visualization is done or information visualization is done? Now, just having said this, so what are the programming languages available for 3D? So you have so many things, VRML. If you just take the MATLAB software, in that we have a virtual reality modeling VRML language. So or the extensible 3D, X3D is available programming language, or scalable vector SVG, or scalable vector graphics available, and many other ones. By gamers, if you just take the gaming industry today, is all depending on the computer visualization. So if you take information visualization is not there, today gaming industry will die. So billions of dollars is industry, the gaming. So then this is what depending upon that. So who was the contributing? Mechanical, the CAD model, CAD people are contributing to that one. Okay, so I'll just show you that later. So now take the 3D objects. So how can this be simple object be represented in a computer? Very simple. I think first diagram, if you look at, this is how we can represent. I think all of you are aware of this. So look at the second one. Ideally is having a highly smooth curve. How do you represent in a computer? It's very difficult. Okay. So then take another one. How about this, like a volumetric body? So like a representation of this in the computer is very, very tough. Okay. So take another one. So it has a soft and hard tissue and different densities and has the interior also. How do you represent the 3D object in your computer? Or take this object. It is composed of different geometric parts. Okay, how you represent in your computer? So this 3D object. Or take this one. This is still complicated. This we have to represent in the computer. With the information visualization or the representation of the 3D object. Or take this. This again, this is a deformable body. I think if you just take the virtual reality, the software for the operation, the surgery or the doctors, what they do, they use this deformable body. Or take animation integration. I think if you have somebody having a habit of playing games, so these are all created in the gaming animation. So these are all the 3D object. Okay, so with this, how do you represent this? Because this is important for all the people. So one is the raw data. So raw data is just like a XY points. So point cloud, range image, polygon soup. This is what they represent in the raw data. Then we have a surfaces. I think I guess you are familiar with this. Surfaces we have a mesh. Anyway, I'll show you that later. Mesh, subdivision, parametric, implicit. Then in the solids we have a voxels, BSP tree, cell complex, and HL high-level structure like a CSG, constant block, skeleton, sweep. So many. I think you take just like point cloud. So simple. Point cloud is an unstructured set of point samples. Okay. So this, how do you capture this point cloud? We get from the rangefinders, 3D scanners, computer vision. Example, if you look at the somebody if is having a Microsoft Kinect. So Microsoft Kinect is the 3D scanner. So whenever you just get that, you get a scanning. So instead of an image, where you image, you get the pixels. So we don't talk about the pixels here. So in the scanners, we get the points. So set of points, point samples. So maybe rangefinders, we get a set of points. So this image, if you look at the rabbit, this is representing a point cloud. So again, this is again bridge with this photo. This is not a pixels. This is a point cloud. I'm not talking the image here. This is a picture which is constructed using a point cloud. So point cloud is I'll define that later. So now, so range image is this set of 3D points that map to pixels at depth image. So this is a range image. So many of the cases in these situations, we use the range image on which you get a range scan from the range scanners. So like, for example, you take the happy Buddha face. So how this happy Buddha face is constructed using the range image. It is the first one. Then using a 3D point cloud. So then tessellations will be done. Or range surface, how do you construct? So these are all we use in your 3D printing, this thing. So now suppose you take a polygon soup. So this is the unstructured set of polygons or unconnected lines of polygons. This is typically we use in our 3D modeling. Okay, so maybe a mug, coffee mug, how is this polygon represented using a polygon. So this simple geometry I'm just talking about. Then the surface object, mesh, subdivision, parametric. So mesh is this. For example, you take the same happy Buddha, or whatever you are represented here. So this I can represent in a mesh. I think this is very common in the 3D modeling. So usually this is a triangles. Maybe the mathematics, suppose somebody is not interested in mathematics, mathematics is very important. So the triangle, polygon, all these things is basically what comes here. So this is, connected set of polygons. So using usually triangle is called mesh. So this we use for making a 3D model or the 3D the picturization. So I'll take the subdivision surface. So coarse mesh and the subdivision rule. So you use this, generate the smooth surfaces with a refinement. Maybe you just look at here how smooth surface is made it using a subdivision surface. Or just take this parametric surface. So this is another one which is bizir, the spline surface patches which you use for 3D modeling. Okay, so you take anything. For example, you constructing this particular picture, we can do using this parametric surface. Okay, then we have a solid objects. Maybe you look at the voxels. So this is a uniform 3D grid of volumetric samples. So mostly acquired from the basically medical imaging, CAT, MRI, etc. So to build this, all those things, we use the voxels. For example, anybody, you want to build a 3D model, then you want to print it like a blood vessel or any medical thing. So we use the voxels. Maybe a combination of things, not just only voxels. Maybe it could be a combination also. Similarly, BSP tree. This is a binary space partition tree with a labeled solid cell. So this is another geometric model which you use for a construction of the any object, any model. Okay, then another one is a cell complex. So look at this, same coffee mug, how it is represented using a cell complex. So cell adjacency graph and cell region. So all these things we use it here. So construct that the complete the model. So now high level structures, what we use? So we use the CSG, constructive solid geometry, which is nothing but just a Boolean set of operators. I think all of you have studied mathematics, union, difference, intersection, subtraction, all those things. So just apply simple samples, simple shapes. So suppose if you're making any IC engine or you want to make a model. So this way, simple, this thing is to use a constructive solid geometry. So very, very making a modeling. So we use this. So similarly, the constraint blocks, the set of simple shapes with a geometric constraint. So we use this for, especially the construction industry, like a 3D homes. You want to construct a home, you use this constraint blocks in that modeling. So generative model, this is a hierarchy of modification operators. So you use this as well. So we use this rotation, scaling, the refining. So we use this many things in this, the generative model for making a modeling. So then the important thing is skeleton. This is a set of connected bone structures deforming a shape of a 3D model. So this again, this is very much used in the medical domain for a 3D modeling, 3D printing and 3D modeling, and then also in the animation. So animation is basically more depending on the skeleton model to make these things. Then especially the utensils and that area, we use the sweep model. So 3D model generated by sweeping the surface along a trajectory. So this particular model is used to in the making a product based on this, the especially household articles and all those things. Then this again, this is a animation and the film industry. They use this scene graph, a union of objects at the leaf nodes of a tree. So this again, this is very much suitable for this, the gaming and other animated images, animated movies and other things. Yeah, so that is the models which you use whenever you want to construct any object or any product you want to design. Those are the models which you use. So then coming to the point cloud, today I think, I don't know many of you have seen the Jaguar car, the high-end model XT or XT, XL, whatever the model. So there they don't use the cameras there for for lane departure, lane detection or anything is like the reverse gear, whatever you put the camera. They don't do the camera. They use the range scanners, the laser scanners. Using a scanner, they get the point cloud. The points they get it. From the point, they construct the image or construct the picture. So this is like a point cloud or becoming a very popular in the modeling and rendering application. For example, when you take a 3D model, before constructing a 3D CAD model, we use this point cloud modeling. So then you make the graph using a graphics, you construct that product. Then you go for a 3D the CAD model. then go for a printing. So point clouds are becoming very popular in that one. And then many of the research initiatives applying 3D point cloud processing substantially, because this is off-the-shelf 3D cameras are available like a Microsoft Kinect. Suppose if you just go to any shopping mall, I don't know how many of you have played the shuttlecock. Shuttlecock, there's no cock, no nothing is available. Just putting that bat like this. That is using a Microsoft Kinect that you do that. So that is a model, 3D point cloud model. Okay, using a 3D point cloud processing, the complete the shuttle badminton the play is made, modeling is done using a Microsoft Kinect. Okay, so because this is becoming the increasing need for the geometric 3D models. I think I showed you a couple of examples already. So a lot of areas we require a 3D model, like a movie industry, games, virtual environment. As I told you, like one is the playing the shuttle badminton or cricket. So maybe if you go to some of the clubs, the high-end clubs, there are a lot of cricket, this thing, virtual cricket playing. So their virtual environment, or maybe you are driving your car virtually, or maybe learning how to become a pilot, airplane pilot. So virtual environment. So those cases increasing, we require a lot of the geometric 3D model. So if you use a conventional model, it's very difficult to construct. So use a 3D model. So existing solutions are not fully satisfying because the user-driven modeling, long and error-prone is required. So that's why people are going for 3D scanners. So it is costly and cumbersome. I think slowly the cameras will be replaced by the 3D scanners. Yeah, maybe. So alternatively, analyzing image, for example, so till we arrive at the laser scanners or the 3D scanners are come into place with a affordable price, maybe still we use the cameras. So maybe in using a camera, we use the image sequences. Cameras are cheap and lightweight, and cameras are precise. Maybe several megapixels, but they're not accurate. But still, it's not a substitute for the scanners. But since the scanners are costly, still people are going for the camera. So using a camera, constructive 3D model. Yeah. So definition is just a point cloud is a data structure used to represent a collection of multi-dimensional points. Okay. So maybe you name any image. So this, whatever the picture you are seeing, so this you can represent in X, Y, Z geometric coordinates. Simple X, Y coordinate, Z, X, Y, Z coordinate with a sampled surface. So when you have a color information is present, point cloud becomes a 4D. So then that's how the point cloud is. Okay, each point in the point cloud, what additional information, for example, color, RGB color, intensity value, etc. So that is what is called point cloud is. Okay. So in a three-dimensional coordinate system, these points are defined by XY coordinate and for intended to represent the external surface of the object. So this, how do you capture this? Which I told you, like using a laser scanners. So you can get the XY coordinates. Okay, so that's what created by the 3D scanners. And yeah, these devices measure in automatic way large number of points. I think if you look at the pixel, if you may get a 512 by 512 or 1024 by 1024, whatever it is. So here, this thing. Whereas here, each picture, if you take a point cloud, you'll get a millions of points. Millions of points. So it's not the thousands, it's a millions of points. Okay. Yeah. So using this like a 3D scanning process, a point clouds you get it, then creating a 3D CAD model. So now I'm just linking. So 3D point clouds or points are available. From there, how do you construct your 3D CAD model for manufacturing the parts, or metrology, or quality inspection, multitude of visualization, animation, anything. So you can use this 3D point, then construct the 3D CAD model. So this is what I'm talking about. So just look at this, the same thing, the image, the picture, the rabbit, or the whatever it is. So this is using the point cloud we are represented. Very accurate, very, very accurate. This is just a collection of points. Okay. Yeah, application which I already told you. So yeah, converting the point cloud to a 3D surface. So now how do you do that? It's simple. I think again a mathematics. So use a Delaunay triangulation method, or alpha shapes, or ball pivoting. A lot of the approaches are available. So use a build of network of triangles, existing vertices of point cloud, and then you make a 3D model, volumetrics or distance field, then reconstruct the implicit surface. So now I'll just show you a couple of pictures later. So you from that the cloud of a manufactured part, align the CAD model, then you make a model. So this is basically what you call. So what is becomes the model. Okay. So now, So what is the sources, the data sources for you? The sources are from the 3D scan or meteorology or geology. So you get from anywhere, the point clouds, maybe experiments or numerical simulation, evaluation. So in the R, you can also get the data from the stereo camera, 3D scanners, time of flight cameras, or generated from a computer program synthetically, MRI or CT scan, whatever it is. So that's where you get a point clouds. Okay. So now what is the processing? Point cloud processing. So now the processing is required because you need to make a 3D CAD model. So now voxelize the data like a T-type structuring to determine the spatial relationship among the points. Then pre-filter. So the processing is same, like a conventional. Pre-filter the data to remove the noise. Maybe non-ground points. Maybe you apply filters to remove apply the morphology filter, whatever. So you have a lot of method to remove the non-ground points. Then the filtered data compute the surface normality each point. So now this data is available to you. Then you take to your robot. So for example, take a point clouds in robotics. Okay, navigation, obstacle avoidance. So you suppose if you just take the race, car race. So you require the obstacle avoidance. Now in the obstacle avoidance, you take the laser scanner, you get the point, then you give the decision. So if there is obstacle is coming, then you have to decide. You should avoid that. So this is what happens in the robotics. So the point clouds are used, which is taken from the laser scanning, then model it, then you give for a decision. So this is basically how they use in the robotics. Okay. Yeah, 3D scanning, you can use the touch probe also, optical laser ranging. There are so many things are available. So there are contact type, non-contact type also available. So various scanning equipments are available. Yeah. So once what is the data you get it? XYZ localization of point, you get just a ASCII file, text file. That's no like a PNG, JPG, not like that. Just it's a simple data file, ASCII text file. Whatever the XYZ location of points you get as a point cloud, this is just a ASCII text file. Okay? So then the level of details you can get it, so file size and all those things you get all those things. Yeah. So the point cloud gives only the position information. Okay, if the intensity, anything required, you have to add that to that particular thing. So once they get that, they scan the object, code the surface if necessary, then use point cloud manipulation software to align and merge the scan results. Maybe what you call stitching. Once you get the scanning, then you have to stitch it. So then once you stitch that, then resampling will be done. Then you go for the triangulation. So this is a model what you use, a polygon model or the constructive graphs, whatever. You can use any, just I'm using a triangulation method to construct the model. So use the process of converting point cloud to a polygon model. Triangulation is a competition, very intensive, competition intensive. 2 points are close together. So this is how for example, I think again a mathematics, curve fitting. I think maybe you might have studied in the 3rd or 4th semester of the BE. So the surface fitting to a point cloud, because this is completely some mathematics. So now get the point cloud, then make a surface fitting. So once you make a surface fitting, for example, this particular thing, what I see, this is an image like this, happy Mudda. So you get a 3D model. So from this surface fitting, you make a 3D model, then take to the CAD model, then you go for a printing. So this is how this works. So point cloud using a surface fitting, then to the 3D model, then the CAD model. You take to the CAD model whatever you wanted. So now, the easy software is available. We have a lot of things, open source libraries available. Point cloud library called PCL. This is available. So this complete framework is free, open source. So you can use this for any of your whatever I said now, the filtering, processing, the service, curve fitting. So all these things, this particular library can be used. This is a completely free software available in the net. It is completely available. Yeah. So maybe also we have the licensed software available called Geomagic Studio, which is a complete toolbox for transforming 3D scan data into a CAD model. So this is also available. So from this CAD model, you take to the CAD software. So now Geomagic software you can use to make this 3D point cloud into a CAD model. So then similarly, another one called 3D reshaper. This is again a processing for the 3D point cloud is available. So which come from the 3D scanner, digitalization, anything. So now from this, which uses the cloud process and the 3D mesh surface reconstruction, then it gives a 3D model. So this is also available, 3D shaper. So like that, there are many softwares available, so which you can use it. So this is one of the first applications developed in the world, which is called LiDAR, which is called light detection and ranging. So this is basically in the helicopter flight. This particular the equipment is put LiDAR, so which uses for the getting the picture. For example, it may be in the height of about 15 kilometers or 20 kilometers above the ground. So it captures all the surfaces: ground, building, trees, utility lines, all things, not water. Okay. So for example, the vehicles parked in the parking lot, is capturing a picture. Okay, so this LiDAR, maybe today the government of India is insisting or made mandatory to use the LiDAR to make a survey. For example, civil insurance do the survey. So survey, road survey, or the irrigation survey, or the wherever there's the catastrophic happened, like earthquake happened, they want to make a survey. So making surveys, physically they do it. But now the government of India made a mandatory to use the LiDAR to make a survey. Where when they make a survey, they get all the pictures. But it's not images. It is basically a point cloud, which they get a XYZ point. So get the XYZ point. So then the complete capturing is happening. So you can just look at. So this is the capturing is happening. So the complete points, millions of points is taken. So this is one of the Indiana city in US, which using a LiDAR, the cloud profile of the Indiana city, which is taken. It is not an image again. It's not a pixels. It's a point cloud. From there, they make up the 3D model. Then they go for a CAD model to print it. Yeah? So you get a millions of very precise laser range measurement made from precisely located aircraft, producing an accurate and detailed 3D map. Maybe a surface at the 1 lakh to 2 lakh pulses per second. Very, collecting millions of billions of precise distance measurement. Yeah, this is one of the tree. Look at the tree. This is the picture. This is the Can somebody mute your mic?
Sir, Suresh.
Yeah, just mute your mic. Suresh?
Sir, you were telling that LiDAR basically is capturing.
You can put your question in the chat box. You can ask the question again.
Oh.
Somebody like Kalmeshwar, can you mute your mic? Kalmeshwar, can you put your mic mute?
Sir, I already muted the mic, sir.
No, it's not muted. Yeah, now it's muted. Yeah, so this provides the detailed images for a vegetation structure. Again, capturing using the flight, the equipment is put in the flight, then the capturing from the height of, so everything. They kept so this is basically the left side is the picture of the LiDAR captured point cloud picture. So this is how they capturing. Yeah, so this is basically a buses parked in the parking lot captured. This is the image, and this is the point cloud. So if using a point cloud, we can we get everything. So what we can do with using a LiDAR, we can find the landslide. We can do so many things. We can find landslides, world cuts, grades, measure ultimate. So anything, you think whatever the list I put it here, we can measure. We can find anything using a LiDAR. Okay, so LiDAR is becoming very popular. Even in India, it is available. Okay, so what you can do in a 3D point cloud in avionics. So avionics is one of the major application of the 3D point cloud because many of the highest level of accuracy is required and quality is required in the manufacturing, repair and maintenance. So this 3D point cloud processing is becoming a very popular. So 3D point processing enables aerospace and engine designers create highly accurate the real world 3D models from the 3D scan data. Okay, so this is basically what the application is coming up. And I'm not going in detail applications and all. So in the automotive, 3D point cloud processing puts automotive manufacturing in the fast lane. So I think today many of the companies like a Porsche, Daimler, name anything. So many of these people using the 3D point cloud in the automotive applications. And I'll show you a couple of examples later. So automotive original equipment manufacturers and suppliers use the 3D point cloud software to make the design and manufacturing process more efficient. Okay, so manufacturers are now they can inspect a component, reverse engineer, like anything you can do it. 3D point cloud processing because software tools, 3D point cloud software tools are easy to use, virtual 3D platform. Okay, and also they can increase the quality using a modern non-content inspection because when you take the content inspection, it may not be accurate. But since making a non-contact inspection, becomes a very easy because, for example, powertrain like a engine or chassis or body or anything you look at. So it becomes a non-contactless inspection can be done. Yeah, couple of just I take the example, the good examples in the automotive. Maybe this one of the example is this. So the example, I'll just show you that example. So this is just it's available. I didn't put in this slide because this is already available in the internet. So there are a lot of examples here. So maybe different companies out there using, automotive industry is using so for example, Ford 3D prints the part of high performance Mustang shell by this is completely 3D printed. So Ford is doing it. So similarly, there is a company, the company Volkswagen, VW is making a 3D printed manufacturing tools. So all the things they're making a 3D printed manufacturing. Okay, complete 3D printed. Or take the local motors and XEV. So on the road, so this is all the 3D printed car, completely 3D printed. It is not the casted and manufactured, 3D printed. Or take this the customization with the 3D printing. For example, take anything we require any parts required, you can customize. Or the 3D printing motorsports. So this is completely 3D printed. This is 3D printed car manufactured. Or take the Porsche. Porsche is the completely 3D printing spare part for classic cars. They're not, they're not making a mold, then making a casting, nothing. They make a 3D printing. Okay. Or take so what will be the future? Motorcycles, it will be 3D printed. So all these things are 3D printed. Okay. So this is a couple of, just to know how the companies are making use of this thing. Maybe if you have any question, keep that at the end. So I'll tell you at the end. I don't want to answer myself. So maybe driving the future of automotive production, a lot of applications going to come in the automotive. So 3D using a 3D printing. So once you go 3D printing, you require a 3D CAD model. If you want a 3D CAD model, you require a 3D model. If you require a 3D model, you require the source like a 3D point cloud. So this is how the flow is. Okay. So similarly, there is other one which is called the 5 ways of 3D printing transforming automotive industry. So it's a lot of changes is happening. Okay, so the complete automotive industry is changing in a very big way, small to big, because this flexible and optimized design can be done here, very, very optimized design. Then rapid tooling is easy because with the additive manufacturing, for example, you need not to do any mold. So we can use the rapid prototyping and rapid tooling can be done here, which cuts the steps and cuts the time also. Similarly, fast and customization via 3D printing. You can get the parts printed within a day or within half a day kind of thing. Then also the validation and advanced measurement on the demand. This is we can do the verification validation easily on demand. Then the real world functional testing. For example, I don't know how many places you've seen the production testing in the companies, whether you go to Bosch, whether you go to any manufacturing facility. The production testing and functional testing is very complicated, very cumbersome, and very expensive. So people are not, because when you, after the manufacturing of the car or a product, they have to do the production testing, they have to do the functional testing. Very, very expensive. We require high-end equipment. So because of the 3D printing, this particular functional testing becomes easy and very less expensive compared to the conventional functional testing, conventional production testing after the production in the factories. That becomes very cheaper and also easy. So this is how the complete automotive industry is changing. So with this, I think maybe scenario, visualize the 3D data, format translation. So how do you do that? Database loading, then data transformation from 2D to 3D. So how you do this modeling in your 3D CAD model? So this is the steps. Then integration of your BIM, CAD, LiDAR, GIS data. Then sharing and publishing a 3D content. Then you go for the integration. VMG. So this is how the model. So this is again another scenario. A geometry model conversion will come. Build surface model from DTM to LiDAR. Then drape the 2D features on surface. So like this is the procedure I'm talking. So powerful query option. Then 3D validation and repairing. Maybe there are a lot of other scenarios as well. Just I don't know. I've taken the 2 scenarios. Depending on the application, depending on the domain, depending on the complexity, we can define the scenarios. So just I've taken the 2 scenarios here. Maybe look at the format. So a lot of formats are available. Like for example, you have a CAD format and GIS format, non-spatial, database, cloud, point cloud. So many. I think variety of things will come. So in this, which is suitable to you, which is then as I mentioned here in the different scenario, you take that then construct the 3D model, then go for the printing. So this is how the 3D model from the 2D data, what will happen. So input data, what is your input data? Building input frames, land use information, or whatever, CAD drawing, heights, or scan data, ortho photos, name anything. So many things will come here. So 2D. Then coming to the additive manufacturing, is just a simple. Because we know the normal manufacturing. So the additive manufacturing just joining materials to make object from the 3D model data, usually layer and upon layer. So you just take if you have seen the 3D printing, how that material is put, I think you can understand that. So layer and upon, I support subtractive manufacturing methodology. So here material is not wasted. Complete material will be used. So layer by layer, they put an object, then they construct this product. So then here advantage here is rapid prototyping. So additive manufacturing of a design, very iterative for form, fit or functional testing. So maybe using easy to prototype it. For example, I want to do a rapid prototyping. So you want any product, any part, any function, we can make this rapid prototyping. So this is the advantage of additive manufacturing. So now just to take a simple some examples of the additive manufacturing. I think why additive manufacturing advantage is that, so you can, even if you want to make one product also. Whereas in the normal manufacturing, you cannot make one product. You have to make millions of product, which has become very expensive and very labor intensive and all those things. Whereas in additive manufacturing, even a one product you can design and then do it. So you make a CAD model, you can print it. For example, take this the medical diagnostics, which is this particular one I can print only one. Then I don't need to print the many objects here. So this is one application. So similarly, take a medical imaging, like this particular application. Again, this is printed, 3D printed, using additive manufacturing. So this has been done for many years. So now dentistry. So even a tooth, the teeth can be printed using a 3D printing. So make a model. So capture the data. For example, when you go to the dentist, your dentist can take this your size of your teeth using a laser scanning system. Then give the data, model it. Then you can give a print, just print. Then doctor, if you're having a printer himself, you can print and put the teeth inside the clinic itself. So this is the dentistry application. Similarly, paleontology. So this is another application which is done using a medical application. Again, using a 3D CAD model. So construction 3D point cloud, then 3D model printed. Again, GIS survey. Again, this is the same. Using the data is captured, made the model, then printed. Okay. So similarly, other application, like for example, architecture and design. This is again a 3D printed, which is additive manufacturing application. So now this is another application. Or this is the entertainment modeling. So again, this is the same. Whatever I explained earlier, using that they made this modeling, and then they use this when they animated movies, animated the graphics wherever they require. Okay, so this is some of the application. So automatic. So name anything, you can just this if you want to do normal manufacturing, very expensive. So using the additive manufacturing, very less cost effective, less expensive, and also easy to make it. Provided you have a model and then you have able to print this. So for example, this is another application. They're making a key. So maybe if you go to a key manufacturer, so making a key, if you have a printer, you just make a model, then print it. It's very simple. So the blood vessels. So today, maybe many people are, many of the doctors, they're printing their blood vessels. So make a CAD model. So the CT scanning, whatever the scanning comes, using that, make a model, then you can print your, whatever the art, using a pacemaker or the camera, whatever they capture. So using that, you can make this blood vessels printed using a 3D printing. Yeah. So similarly, even a construction of an house. So the house is constructed using a waste material. So this is the 3D printing of a house using a 3D printer. So you can design, then you can print this house also. Yeah. So this is another application, Coca-Cola with the 3D printer. You have a recycled bottles to make this using this 3D printer. Yeah. So with this, I think 3D printing, a lot of the key transformation shift is happening. So mass production to the mass customization, and supply chain focus, maybe from push to pull is happening, and the forecasted demand to real-time demand. Because earlier, for example, how many Maruti cars required, they used to estimate. So maybe this year you may sell about 1,000 cars, manufacture 1,000, keep in the supply, the godown. So now it's not that. So based on the demand, they make the print this and then produce the cars. So manufacturing global to local. So this is becoming easy now. So yeah, manufacturing, it becomes easy. Produce 3D parts and assemblies made from the various materials in a single build. More efficient designs, reduces the need for tooling, machining, handcrafting, and reduces the need for maintaining the inventory of a physical modes. So here we don't require anything. Yeah. So early adopters, maybe many of the companies, the sectors are adopted, automotive and the consumer goods and all those things. So now today, so sports and entertainment also adopted this 3D printing, this thing, and textiles is more and more in adopting. So maybe days to come, years to come, you have a lot of demand for this 3D printing in the, especially in the textile thing. You know, textiles is one of the major the demand. I think the demand and the lot of the products are printed using 3D printing. And yeah, so this is the thing. Then yeah, so that's all from my side. If you have any question, you can ask me, and then I'll answer to your question. So if I'm not able to answer, I'll maybe come back to you later. So ask the question related to this, and maybe look at this. Don't look at this as a threat for you. It is not a threat for us. Basically, it's a boon for us. Basically, in the coming years, the conventional mechanical industry will be transformed to a non-conventional mechanical industry. For example, today we have a big mechanical production centers. Many of these, like go to Toyota or Bosch or anybody, there's a lot of big manufacturing facility. Maybe in years to come, maybe wherever you are, you can put a production center. Maybe we require a 10 by 10 room. That's all. Just have a 3D printer, produce it, you export. So you need not to set up this big center. You don't require machine. You don't require anything. So you require CAD modeling software and system plus the 3D printing. So you can do that. So anything, whether you take automotive or the medical, consumer goods, any industry. So maybe in the days to come or years to come, so the complete manufacturing facility will be decentralized. Maybe that's how this 3D printing is evolving and then coming up. Maybe so that is the reason why there are a lot of courses being offered now at the BTech level, MTech level, maybe diploma level also. People are starting now. Maybe in a couple of years, maybe something like a BE mechanical. We have a 3D. Already we have today this way in the JSS. We are starting the 3D printing and process automation. We are starting the BTech program or BE program, and also there are MTech programs also we are starting in Mysore. So like that, a lot of programs are started. Maybe in the next 5-10 years, this will revolutionize. This is what the industry prediction. Maybe you can just search the from the Frost and Sullivan or the many of these analyst companies are given the roadmap or the future. What is the future? It's available in the net. I don't think you need to buy. So you have a lot of things available already. You can read that. So that's how the market is. So wherever you fit in first. So because you change your mindset. So this I have to learn. This is how I can progress. This is how I can learn. Then I can use this. I become an expert. Then I give the service, or give the service, give the solution, or give the design, whatever. So a lot of things are coming up. So in fact, at the JSS level, so maybe another 1.5 year or the 2022, we are starting the big center in the biggest center in India, JSS Academy of Product Design, which we are going to start soon, maybe in another 1 or 2 years. We applied. Then we are already designed the course, what is the research, what is the thing to be done. So a complete facility we are going to create in India. So that is happening. Maybe a lot of the universities and industries are investing time and money to make this happen in a bigger way. So this is how the things are moving. Yeah. So if you have any question, if you are putting the chat, I'll just take from the chat. Otherwise, you can ask me. Yes.
I find no questions in the chat box, sir.
Yeah.
Boys, any of you would like to ask any question?
Yeah, any question, feel free to ask me, because even I want to learn from you. So this is what I understood this, and then whatever my perspective, I put it here. So if you have any other perspective, please.
Gagan Sir, he has raised his hand, sir. Gagan Sir, you can ask the question. Gagan Sir has raised his hand.
Yeah, can just.
He's not there.
Sir, good morning, sir. Myself, Kalmeshwar. mechanical
no, no.
aspects. Sir, so as you told earlier, the means cloud on the cloud point, you are going to capture the surface of the model. Suppose if the model is very depth and level, so is there any other options to scan the model, or only cloud by cloud point only you can capture it?
No. You have various methods. One is the laser scanner. You can use it. So
Okay.
laser scanners today we are getting at the affordable price.
Okay, sir.
So earlier it was very expensive. Now today you get a very less cost itself. You get a laser scanner. So laser scanner is one method. So other method is a simulation, like basically the CT in medical application, the CT scanning, MRI, all those things we get the data from there also. So other one is basically the use the cameras itself, high-end cameras, the dual camera or something like that they use, but that is not accurate. That's not an accurate.
Okay. So and one more question, sir. Which parameter is going to mainly affect on the taking the cloud points? Okay, which parameters mainly affect on that?
No, which parameter means like for a 3D scanner point of view or the image, the picture point of view?
The 3D point of view, sir. 3D printer point of view.
No, not 3D printer. So basically, say when you use the laser scanning, more if it is a more accurate, more the precision is more, then you'll get more points. For example, instead of million, you may get a billion. Then it becomes more accurate. For example, if you're constructing a alt vessel, like basically a blood vessel or something, or this thing, so then you require more accurate. So at that time, maybe you require the accurate laser scanning system. For example, it's a typical, they do this. What is this called? The people who do that. They leave the camera inside the body. They capture that the image. So like that. That is how these things are working. Now you measure what is your art shape. Art shape where you require to replace that, like pacemaker they're putting today, right? So you measure that what is the shape and accuracy of that. So you put the camera there inside the body, then they take the picture. So you capture the points. So now based on that point, you're going to make a model, then print the alt vessel or whatever it is. So like that accuracy of that depends on the scanner, the accuracy of the scanner.
Thank you so much, sir. Thanks a lot, sir.
Thank you.
Sir, this is Dr. Anil Kumar, sir.
Sir,
you said like scanning of the what is that? Any object which is placed using this laser scanners and all. So once it is a reverse engineering kind of CAD model which is built using the reverse engineering.
No, it's not reverse engineering. It's not a reverse engineer. For example, you are traveling in a car. Okay, so Jaguar car. Then you want to identify the lane detection. So lane detection, for that you use the laser scanner. For example, any product, for example, you take a real-time application I'm talking. For example, you take the teeth. So you go to dentist and you want to replace that teeth. So if you want to replace the teeth, they can take so that is basically where you require the scan the size of that. Size of that. It's not reverse engineering. See, so reverse, for example, take Eiffel Tower. So I want to make an Eiffel Tower model. So how do you make an Eiffel Tower model? So one method is you using the mathematical model. You construct the Eiffel Tower. Or take the picture of the Eiffel Tower. So using a laser scanner or the lidar or whatever. Then from that you derive the model, 3D model, and then print that model using a 3D printer. It's not a reverse engineering. We don't call it reverse engineering. It's a modeling.
So generally what I mean to say is in the CAD modeling, CAD techniques, one way of extracting the information is a reverse engineering. The second way is direct creating the new model. And third one is like by using a scanner like MRI scanners and CT scan. So I thought like it comes under the
no. Scanner is not a CT scanner, a MRI scanner.
Okay.
A laser scanner is a different, just like a camera.
Okay.
Whatever today you have a camera, like that, then the laser scanners are available, not a CT scanner. CT scanner is one among them. Laser scanners are available. For example, if you take a Microsoft Kinect, if you're playing a game, people who play a game, they know very well. So the Microsoft Kinect is very popular. It's there for last 7-8 years. So then similarly, there are a lot of scanners available, laser scanners. Not like, don't imagine the printer scanner. That is different.
That is different.
Not that scanner I'm talking.
So in the future, does it really going to replace the additive manufacturing and the subtractive manufacturing and the formative manufacturing, which is purely mechanical? Is it going to replace with this?
It's not replacing. It's not.
It can be
It's a supplementing.
Okay. It's like a support.
Overnight, because I'll tell you from the perspective of a business person. Suppose if I'm a company owner, I don't want to close my company, I close my manufacturing facility, then give this. So that the people not do, because they already invested billions of dollars.
Yes, sir. Right.
That will continue till that line of manufacturing is required. Suppose I want to change that line of manufacturing, which is outdated and old. Then if I want to go for a new manufacturing, I may not do it. I go for additive manufacturing completely. That's how the companies invest money.
So you mean to say it will be a third pillar for the supporting manufacturing, like with the subtractive manufacturing and formatting manufacturing, this will be a supporting for the manufacturing.
Not supporting, it is one of the other way of doing the manufacturing.
Okay, sir.
So there is a question from Bharadwaj Manta. Does the 3D printing industry need any tweaks to go into the mainstream production for affordability? I think answer to your question, Bharadwaj, is there's no tweak required. This is basically the industry. For example, today, how many people buy the Porsche car? Porsche car, hardly, maybe there's a market only for 10 or 20 cars they sell. That particular model I'm talking. It is not like a mass manufacturing they do. They sell the 1 lakh car, 2 lakh car. So when they go for this, designing the car for 10 or 20 cars, or maybe manufacturing 10 cars, if you go with the normal manufacturing, so subtractive manufacturing, it's very expensive. So then what they do is they go for the 3D printing. There is some additive manufacturing. So now, for example, I have a requirement for a car. I'll give the requirement to the Porsche. You give me a car like this. So if I want to design, then I go for additive manufacturing only. Okay. So or take a teeth. For example, teeth size of me, teeth size of you may be different. So then you cannot go for subtractive manufacturing. Then people go for additive manufacturing. So that what I'm trying to tell is, wherever there is a mold, where there is a mass manufacturing is not required. So people go for this. For example, somebody guest comes to the college. I want to give the gift to him. Some gift, a memento, I want to give it. So he likes the memento, some memento, he likes it. That is not available in the market. So how do you get it? So maybe you have to give an order. You have to tell him to manufacturing only one. You will not do it, because that becomes very expensive. He may charge you about 50,000 rupees or 60,000 rupees, which is very expensive. So what I'll do is I'll use a 3D CAD model, construct that model, then use a 3D printer, print it. It may cost you about 2,000 rupees for me. That's okay. So this is like basically what I'm trying to tell is, the 3D printing industry will go wherever you require a rapid prototyping, rapid the time to market is very less. Then the cost you want to reduce it. Then you can go for that. So if this is the mass manufacturing, they will not. For example, take the garment industry, textile. Suppose we are making a particular the T-shirt. We are making a T-shirt. So the market for the T-shirt is millions. Then I'll go for a mass manufacturing. The market for the T-shirt is only 50. Then I'll not go for a mass manufacturing or a subtractive manufacturing. Then I'll go for a 3D printing. So use the material what is required for that T-shirt. You print using the 3D printer. So this is how this 3D printing industry is evolving. Maybe in the days to come, each and every village or every small town, we will have the manufacturing center. That means the mechanical engineer sitting at home, they can do this 3D printing industry, they can set up. So you can export, you can import or whatever, you can do that. And that's how the things happens. There's no tweak required. That means you will not going to force anybody. So the market will decide to go that.
Sir, excuse me, sir. This is Murali Siddesh from Mechanical Department, sir. I have one question, sir.
Yeah, please.
Sir, while going for a production, any product, while finish up the product, we are giving an heat treatment or like that. But the 3D printing, you have any chance to get parallelly, we can, while printing only, you have any heat treatment and those processes parallelly?
Yes, that's what I mentioned in my slide. In you can get mute your mic. Mute your mic.
Oh, okay, sir. 1 minute. Oh, okay, sir. Okay.
Yeah. So now that is possible, because in subtractive manufacturing you are doing that heat treatment. Here also there's a laser. This thing is possible. So that's why in one of the slides I mentioned that. So if anything such kind of required, that can be done. Maybe again, if it is not available, that is a research topic for you. You do the research and then do whatever, how to do that. So suppose it's already available, improve that. So improving that, you can do it. So it's available. Certain extent is available, not completely. Because certain things which, as I said, certain things you have to go with the conventional or subtractive manufacturing, which may not be possible in this thing. So because we're still in the nascent stage, research is happening, people are doing the research. Then once the research completed, then the problem it will come to market. Yeah.
Thank you, sir.
Yeah,
Thank you. Thank you.
yeah, thank you. So any other questions or any other inputs? Somebody?
Yeah, Dr. Anil. Anil, sir?
Anything?
Sir, yeah.
Any questions from anyone?
Any question from the student side?
Yeah, so thing is that so this particular 3D printing, I'll tell you a couple of subjects, because in the mathematics, because I'm just not watching mathematics, but I'm just telling my experience. Differential geometry is the one which is required for this particular area. For example, if you're going for additive manufacturing, product design, or this 3D printing, the differential geometry. So you need to learn. Maybe it's not that you have to study. There are a lot of the courses are available in differential geometry, and this differential geometry, a lot of the research has happened already for many years. Then a lot of models are available, the material is available, so that you can use that for your modeling. So for enhancing your knowledge and learning the things. Now differential geometry. Other than that, I think all other subjects which I already told. Yeah, we can do that. So with this, I stop here. So thank you so much.